हेलो एंड वेलकम। वैसे तो इस वीडियो में जो क्वेश्चन हम करने जा रहे हैं वो सभी स्टूडेंट्स को मज़ा देने वाला है, लेकिन क्लास 11th के स्टूडेंट को कुछ ज़्यादा ही मज़ा देने वाला है। आइए देखते हैं हमारा आज का ये प्रॉब्लम जो काइनेमैटिक्स के ऊपर बेस्ड है। In a metro rail system, the train velocity varies with time as shown in the plot. The graph has been shown in dark red color. The vertical axis represents velocity in kilometer per hour. Here it is 90 kilometer per hour. And the horizontal axis represents time in second. This time interval is 15 seconds. This is delta t and this is 15 seconds. The train runs 600 meter between stations A and B from rest to rest. Train starts from rest at station A and then ultimately comes to rest at station B. The separation between the distance between the two stations is 600 meter. From start to attaining the constant speed, the velocity time graph is of the form a plus bt plus ct square plus d into t raised to the power 3, where a, b, c and d are proper constants, which means ये ग्राफ का हिस्सा स्टार्ट से यहाँ से स्टार्ट करके कुछ दूर चलने तक ट्रेन एक्सेलरेट होती है, फिर उसकी वेलोसिटी कांस्टेंट हो जाती है जैसा ग्राफ में दिख रहा है। स्टार्ट से वेलोसिटी कांस्टेंट होने तक ये जो ग्राफ है ये एक कर्व है जिसका इक्वेशन क्यूबिक है। वेलोसिटी इज चेंजिंग विथ टाइम अकॉर्डिंग टू दिस इक्वेशन, वेयर स्मॉल a, स्मॉल b, स्मॉल c and small d are proper constants of proper dimensions. At the end of the run, before stopping, the VT graph is again a similar cubic curve. This part of the graph is again a very similar kind of cubic curve. Both the curved parts of the graph are mirror images of one another. These curved parts are mirror images of one another. The slopes of the cubic curves are 0 at the end points. The slope of this red curve is 0 here, it is 0 here also. And both are symmetrical about their own midpoints. Imagine a line passing through the origin and the midpoint of the first cubic curve. The curve is absolutely symmetrical about this line. I leave this statement for you to decipher what exactly it means. Determine the total runtime t between the stations. I am getting out of the frame for a moment. You can capture the shot and please give it a try. Definitely give it a try before you go through my solution. Here I proceed with my solution. The question can be solved in two ways. One way is to find all these constants and write the variation of velocity as a function of time. There are enough conditions given in question to be able to calculate A, B, C and D. I leave that method for all of you to give it a try. But what I want to demonstrate is something very simple, very elegant. This is the part of the graph from 0 to 15 seconds. It is a curve represented by some cubic form. Okay. In 15 seconds, the distance traveled by the train is given by area under this graph, right? This is the graph, velocity time graph, and area contained inside this graph and time axis gives you the distance traveled. So how much distance the train travels when it accelerates, when it speeds up? That distance is given by this area. I have magnified that graph here. This is 15 seconds, right? Now, if you read the last part of the question carefully, it says that this cubic plot is symmetric about its midpoint. And if you imagine a line passing through origin and midpoint of the curve, a line like this dotted line, then the curve is exactly symmetrical about this line, which means this part of the curve, just a moment, this part of the curve, this part of the curve and this part of the curve, they are symmetrical about this dotted line, which simply means this area is equal to this area, which means if you are trying to find area under this red curve and time axis, you can easily do it by writing area under this dotted line and time axis. Both will be same. Area under the red curve and time axis, it will be same as area under the dotted line and the time axis. I hope you get that. Now that area is very easy to calculate. This triangle and area of that triangle is half into base into height, which you can write as half into Vmax. Vmax is this maximum speed, which is 90 km per hour. Converted into meter per second, it is 25 meter per second. So half into this height, which is Vmax, 25 meter per second, into this time, which is 15 seconds. So if you do the calculation, it is 187.5 meter. So the train travels a distance of 187.5 meter during its acceleration phase. Then for some time it travels at constant speed and then again deaccelerates. Now when it deaccelerates, this curve is mirror image of that. So again, area under this part of the curve and time axis will be same, which means the area will be same as this much only, which means during the acceleration and the retardation phase of its motion, train travels 187.5. So total distance traveled during acceleration and retardation is double of this, which is 375 meter. Overall station to station distance is 600 meter. Out of that 600 meter, 375 meter was traveled during acceleration and retardation. So remaining 225 meter of distance was traveled when train was moving at constant velocity, at constant speed. I hope you get that. 225 meter at constant speed of 25 meter per second. So traveling 225 meter at a constant speed of 25 meter per second needs 9 seconds. So train was actually accelerated for 15 seconds, then it moved at constant speed for 9 seconds, and then it retarded for 15 seconds. So the total travel time is 15 plus 15 plus 9, that is 39 seconds. What I said in the beginning, you can actually by reading the question properly, you will be able to write enough number of equations to get the value of A, B, C and D. And if you can do like that, you can actually integrate V dt to get the distance traveled in first 15 seconds and last 15 seconds. Give it a try that way also.